Bismillahirrahmanirrahim. Assalamualaikum and hi everyone. Okay, now we will talk about the passive circuit elements in frequency domain. Okay, actually there are two types of circuit elements that you can have. First, it can be passive circuit elements, and second, it can be active circuit elements. Okay, for passive circuit elements, we can say that this element actually no need to have any power supply to power them. Okay, that is for the passive element. Okay, but as I mentioned here, okay, this one we talk about the passive element. But when we talk about the active circuit elements, for this type of elements, we need to have a power supply to power them. Okay, to make sure they are working, we need to power them up. That is for the active circuit elements. So the examples of passive circuit elements are resistor, inductor, and also capacitor. So this is what we want to focus now in this video. Okay, so I will explain the VI relationship for these passive circuit elements into three parts. Okay, the first part is about the VI relationship for resistor. The second part here is the VI relationship in inductor for inductor, and also the third part is relationship of VI for capacitor. Alright, so let's move on to the first part. Okay, so first of all, when we want to talk about the VI relationship for resistor, okay, we can imagine that we have a resistor here with the plus minus, and the current will flow from the plus to negative, and then we will have the voltage here, and this is the value of the resistor. Okay, now let's say the current is flow through this one, and let's say we assume, okay, the I equals to Im cos omega t plus theta I. Alright, and we also have learned before this that when we use the phasor transform, okay, from the phasor transform, we will transform the signal or the current I here into the frequency domain. Okay, so in the phasor transform, we will have the capital I instead of I here to show that this current now is the frequency domain, and we will look at what is the value of the Im and what is the value of the phase angle or the phi here. Okay, so in this case, we have the first part is Im here. Then we can actually rewrite this I in terms of phasor transform as Im, and with this symbol is to show the phase angle or this phi I. Okay, so based on this, when we want to write about the relationship of voltage and current, okay, so we will use the formula of V, which equals to Ri, and this is based on the Ohm's law, that we will have resistor R multiplied with the I. Okay, this is in terms of the time domain, right? So the I here is now given by R. Okay, I is Im cos omega t plus theta I. Okay, now when we transform this in terms of the phasor transform, so I will use this notation capital V, and we assume that this is now bold. Okay, this B is bold, is to differentiate this symbol with the capital B without bold. Okay, so this capital B with the bold, okay, is to show that this voltage is now in the frequency domain after the phasor transform, and it will equal to R, okay, multiplied with the I, which is also in the phasor transform. So when we write this, we will have R multiply with the Im okay, with the theta I. Okay, and sometimes we can also write this as the R multiply with exponent J, so this is Im, exponent J theta I. Okay, so they are actually the same thing. Alright, so this is the relationship for the VI, relationship for the resistor. So in this case, it is very straightforward that when we talk about the relationship of voltage in the resistor, for the resistor, so it has the equation of V equals to RI. Okay, so now I can rewrite here that this V equals to IR. Okay,